Yep.
Get started. Hi, our team represents the Project AI Spark Flows, a tool for fast and small savable workflows for Spark data analysis. The team includes me, Charles Horn, John Bentley, and Mason Mings. AI Spark Flows is a dashboard that allows users to input a desired analysis workflow performed on Spark datasets to do machine learning and descriptive analytics. The requested analysis is used to generate a prompt that is sent to a large language model, in this case, ChatGPT, using the OpenAI API, which in turn generates a Docker file and a Python script file that is returned to the user. The user runs the Docker file to create a Docker image with an appropriate analysis environment and built-in Python script to complete the analysis. So why use this tool? There are two pain points that we deal with for analyzing Spark data, one of which is fast preliminary analysis, and the second one is to create small footprints of saved workflows, both of which align with our goals and benefits to the Spark community. Second and thirdly, I want to mention that our approach is lightweight, dashboard implemented in the cloud or locally for the creation of workflow files, including this Python script and the Docker file. And we see this as highly feasible in the sense that we have lightweight files implemented quickly in the cloud, and we also can train the model, again, on large language models that might be open source in the future.
The dashboard is implemented with a Flask backend and a React frontend. To install it, simply clone the Git repository, then navigate to the dashboard directory, then run npm install and npm start. For the backend, navigate to the backend directory. Make sure you have the Python library prerequisites installed through pip, including Flask, OpenAI, TikTok, and PyYAML. Then start the server by running python server.py. Make sure you have your Open API key in the directory above the GitHub repository. Set up your local directory structure by having a subdirectory named results and another subdirectory named data. Then go to the sparc.science repository, select your data and download it to the data directory. Make sure the data is in an appropriate format, such as CSV, Excel, or XML. With further development, AI can be used to format the data.
This is an image of our dashboard. We have 4 inputs that we feed to our backend, which then generates a prompt that we feed to our model. Those 4 inputs are the analysis type that we want to run, the file type of the data that we run the analysis on, the included Python packages that will run in the container, and a short data description of the data set that we will be running our analysis on. Once these inputs have been placed, the user will click the generate button, which will then generate the Python script and the Docker file that the user will then download by clicking the 2 download buttons on the bottom of the screen. Once the files are downloaded, the user will place them into a directory similar to the structure that John mentioned previously. And then navigate to that directory, build the Docker image, and then run the image, and then run the container to perform the analysis. The analysis will then, and other generated files will then be placed into that directory, according to similar to the image seen in the bottom right-hand corner. The output and results will be sent to the results.txt file. In the future, we're very excited for the directions that we can take this model. Obviously, we can aggregate multiple data sets into one. We can use open source LLMs instead of the OpenAI, which is not open source, and hopefully train those. Obviously, placing this on the cloud is very exciting. To be able to alleviate hardware resources constraints and potentially difficulties downloading and using this tool locally. And hopefully we'll be able to place this in a place that has high availability and will increase the ability for users to access and utilize the amazing data sets that Spark has provided to the public. Thank you very much.